Hello everyone. So I will tell about how to do this input and output characteristics of bipolar junction transistor using this SEE Lab this module. Okay. So if we look at how this input and output characteristics will look like, if you see this diagram, so this is one NPN transistor. So this one is emitter, this going arrow, and this is the collector, and this is the base. So this is connected in common emitter mode. So this is NPN transistor connected in common emitter mode. Okay, so for input characteristics, so basically we have to find out across this base the current voltage graph, and for the output characteristics we have to find out the current voltage graph for across this collector. So basically with collector to emitter. Okay, so if we look how it will look this graph, so at input, since they are in the forward bias, so they will be like PN junction diode in forward bias, and the output graph will look like this. Okay, so this we have to do using this SEE lab kit. So before making the connection, so what we will do, we have lot of resistance. So we'll identify few resistance. So here I have identified two resistance. So this one is 100 kilo ohm and this is around 1 kilo ohm. So these two resistance we will be using to make this circuit. Okay, so if we want to make this circuit, so what we will do, we will use one transistor. So we'll be using this transistor. So if you look at this transistor, so here one curved surface is there and one flat surface is there. So with respect to this flat surface, if we see this right side one is your emitter, middle one is base, and the left one is your collector. So let's connect them here. So here I am going to put these three in this breadboard. Okay, so I have connected them. So here this right side is our emitter side, middle one is the base, and the other one is the collector. Okay, now if you look at this circuit, so emitter is connected to the ground. So here our emitter is this one, so this will connect it with the ground. So take any of the ground and you connect it with that. Then the other part is, so we'll go to this base. So base is connected to first E2 and also with 100 kilo ohm resistance. So here in this transistor, so base is the middle one. So we'll connect this middle one with E2, so that will measure the voltage across this base. And the other terminal of this base is connected with the 100 ohm resistance. So here I have taken the 100 ohm resistance. So with this middle one I am connecting here, and if you see the circuit, so the other terminal of this 100 ohm resistance is going to PV2. So here this terminal is going to PV2. So we'll connect it to PV2. Okay, so base connection is done. So we have connected with A2, ground for this emitter, and this one with the PV2. Now we'll connect the collector side. So collector side, so from the transistor immediately there are two connections. One is going to A1 and another one is going to 1 kilo ohm. So first we will connect this collector, means here this left side. So this should go to A2, sorry, this should go to A1. Okay, so this is connected, and from there itself another resistance 1 kilo ohm, and the other terminal of the resistance is going to PV1. So this terminal should go to this another resistance I have taken, this is nearly 1 kilo ohm. So let's connect it here, and from the resistance, so resistance I have connected here, so from this resistance it should go to PV1. So here we will be connecting with PV1. Okay, so our circuit diagram is complete. So now we can connect it with the computer and we'll check with that software. Okay, so let's open that software, SEE Lab software, and we'll plug this. Okay, now if you see here in this electronics option, there is one option NPN output characteristic. So NPN transistor output characteristic. So we'll select this one. Now what you have to do, if you look at this corner, so here it is written V base. So that means here we can control the base voltage, that is our input voltage. Okay, so currently it is selected at 1 volt, so we can start from some lower volt. Let's say we are starting from 0.5 volt. So I have selected here, 0.5 volt. Okay, so let's start. So if we see this input voltage is very less, so we are not getting any current output. So let's increase this input voltage. So we'll increase it to 1 volt. Okay, so now we'll start once again. Okay, now you can see we are getting some output, and this behavior, this graph is exactly like what we have already seen for this transistor output characteristics. Like for this graph, so this is our output characteristics. So this image I have taken from NCERT book. So for a particular input current, so here for example 10 microamps, so we observe this. Now coming back to our results, so how much base current here it is? So it is just 3.6 microamps base current. Okay, so it's quite low. So what we will do, we will increase this input voltage. So let's increase it to 1.5 volt and start once again. So now we can see this output voltage is also increasing, and this is the saturation region. Okay, so we can see the base current is around 8.3 microamps. So we can increase this input voltage further. So maybe we can increase it to 2 volt. Let's start once again. Okay, so we got some output with input current of 13.2 microamps. So this is our output characteristics of this bipolar junction transistor. Okay, so this is your output characteristics of this transistor. So the first part of this experiment we have finished. So this is the output characteristics. So if you want to save the data, you can save this data in the text format and you can plot it. Okay, now there is another part, that is your input characteristics. So how we will do the input characteristics? So what is input characteristics? So basically in the input we are going to vary the base voltage and we are going to measure the base current. And the graph, if we see, this graph will look like this. So it should exponentially, it should increase. Okay, now coming back to this circuit diagram. So if we want to know the base current, how we can find out the base current here? So if you look at this 100 kilo ohm resistance, so across this PV2, this is our applied voltage, and this A2, this is the measured voltage. So let's say here I am applying some voltage 2.1 and here I am observing some voltage, let's say 1.5. So this let's say here I am applying 2 volt and here I am observing 1.5. So this 0.5 voltage is the voltage difference across this 100 kilo ohm. So if we divide with this resistance, so we'll get the current value, because we know from the Ohm's law that V equals to IR. So if we want the I, then V divided by R should come. Here the V is the voltage difference across this PV2 and A2. So basically if we increase the voltage across this PV2, so your current will increase through this, and to find out what we will do, we will find out the value of A2, and this value of A2 will subtract from our supply voltage, this PV2, and we will then divide by this resistance, then only we will get the current flowing through this. Okay, so if we want to do this, then what we have to do, we will keep this output voltage constant. So let's say we will set constant at some voltage, 1 volt or 2 volt, or we can keep at multiple volt. First we will fix at 2 volt, let's say, then we will vary this PV2. So if we set okay, so now come back here. Now here what we have to do, we have to go to this electronic option, then we have to go to oscilloscope, and we can see that here we can control this PV1, PV2. So PV1 is basically your output voltage in that CE, collector emitter terminal voltage. So we'll set it at around 2 volt, let's say. So if we click here, it will increase by 0.01. okay, so this is PV1 is at 2 volt, and PV2 will start from the 0. So bring it back to 0. Okay, so PV2 is basically your input voltage. Like if we see once again the circuit, so here this PV2 is our base applied voltage, and A2 is the voltage measured on the other terminal of this resistance. So this is basically your base voltage, base emitter voltage. So now if we see here, so we have to change this PV2 by very small amount. So let's say here if I increase this 0.1, okay, so you saw the value of A2. So this A2 value we have to note down. So when this is 0.1, this A2 is around 0.09. Now move it to 0.2. okay, so this is almost like 0.2, and this voltage is around 0.19. Now increase it to 0.3, 0.3. so this voltage is A2 is around 0.28 or 0.29. Now go to 0.4. okay, so for 0.4 we are getting 0.37. now increase to 0.5. for 0.5 we are getting 0.46. so what you have to do, you have to take pen and paper, and then you have to note down all these values. Like for example, so here we have to note down the value of VBE. so that is basically we are changing that PV2. so this is one column we will draw, and the other column is A2. so A2 is the other terminal voltage of the resistance. So when we started with the 0, so it was almost 0. so when it was 0.1, it was around 0.09. then we went to 0.2, so it was 0. around 19. then 0.3, it was 0. around 28. 0.4, it was around 0.37 if I remember. Then for 0.5 we got the value was around something was 0 there, 0.45 or something. okay, so we'll come back here. Yeah, so for 0.5 it was 0.46. yeah, so this is 0.46. so like that you have to continuously increase with 0.1 interval. And if we go to some little higher value for PV2, so let's say 0.9, 0.6. for 0.6 you got 0.54. so 0.6, 0.54. now increase it further. 0.7, this is 0.3. 0.59. Increase it further, 4.8. We got 0.61 or 62. 4.9, we got around 0.62. Then if I go to around, let's say if I go to 1.1, okay, so this is around 1.1, so we got the value of 0.64. So like that you increase to certain extent, take at 1.2, 1.3, 1.5. so now if we see this value, we have increased to almost like 1.8, and we got the current value of 0.66. okay, so this is the data. Now from this data, so what you have to do, you have to subtract A2 from VBE. So VBE, that means your P V2 minus of A2. Okay, so why we are doing this? So this is the voltage across the resistance, and you know the resistance is 100 kilo ohm. Okay, so if we put these values, so we'll get the current. So this will be the current across the base, that is IB. Okay, so you'll get for all these values current across the IB. So you do it in Excel so that you can easily calculate this current. So then what you have to do, you have to plot this input voltage. So what is input voltage? So this voltage what you are getting, so this is basically the voltage across the resistance, and the voltage across it, this one is our increasing voltage, input voltage. So this we are changing, and the current value also will be increasing. So you will plot one graph. So this will be like VBE and this current IB. Okay, so this graph will be like this. So you'll get a graph like this. So this is your input characteristics of this transistor.